Hi everyone. In this video, we'll go through partial fractions, different topics related to partial fractions. That is, how do we resolve partial fractions or proper fractions? How do we resolve partial fractions when there are repeated factors using coefficients and constants? And then resolving partial fractions for improper fractions. The process of splitting rational fractions into simple fractions is called as resolving into partial fractions. Now, in this particular topic, we learn how to resolve rational fractions into partial fractions. Now let's take this first topic where we have a proper fraction given and we'll have to resolve it into partial fraction. Now, how do we know if it's a proper or improper fraction? We'll have to find the degree of the numerator. Degree is nothing but power of x, right? Here the power of x is 2. Here the power of x is 1, right? Here there is no x. So, but the highest power of numerator, what is the highest power of numerator? 2. So this 2 is the degree, highest degree of numerator. So I would call this as numerator and this is denominator. Now what is the power here? When you multiply this denominator with this particular term and this particular term, you're going to get x cube, is it not? X square into x is x cube. Then what is the power? Power is 3. Now you see that the degree of numerator is less than degree of denominator. Hence this is a proper fraction. Now let's solve this particular problem. We'll have to split this into partial fractions. We have this quadratic equation here, right? First we need to factorize these equations. It has to come in this form, like x plus 1 or x plus 2. There are multiple ways to factorize: sum product method, formula method, direct method, right? Now, if it is simple problems, we can factorize it directly. If it is slightly complex, then we might have to use formula method. And for some problems, we can use sum product method based on the complexity of it. Now here, we have this particular quadratic equation. We can use formula method. This is the formula, minus b plus or minus b square minus 4ac by 2a, right? A, b, c are the coefficients. So in this case, a is equal to 1, b is equal to minus 5, c is equal to 6. So we'll have to take the signs also. Take these coefficients, substitute in this formula, and then you'll get two values of x. One is when you add, when you use plus, and the other one is when you use subtraction, right? So you'll get two values, 3 and 2. The way we have to write these factors is, here we have got directly x values. So we've got x is equal to 3 and x is equal to 2. So we'll have to write this as x minus 3, x minus 2. Why? Because when x is equal to 3, if I shift 3 to this side, I'll get x minus 3 is equal to 0. And when I shift 2 this side, I'll get x minus 2 is equal to 0. So the factors are x minus 3 and x minus 2. The other method is sum product, right? Here you'll have to choose two numbers in sum product. So minus 5x plus 6, x square minus 5x plus 6. Choose two numbers such a way that this is the sum and this becomes the product. Right? So now sum has to be minus 5. So you have to choose two numbers, number 1, number 2. And when you add these two numbers, you should get minus 5. And when you multiply these numbers, you have to get 6. So we can take 3 and 2, because when we multiply in 3 and 2, we'll get 6. And when we add 3 and 2, we'll get 5. But we'll have to get minus 5. That means both of these numbers should have minus, because when you add minus 3 and minus 2, you're going to get minus 5. And when you multiply minus 3 and minus 2, you're going to get plus 6. So here we get minus 3 and minus 2. The way we'll have to write this as x minus 3 and x minus 2. This is how we'll have to write it. Direct method. How would I do it in the direct method? This is like this, right? I'll have to split. This is direct method. Split minus 5x into two terms. So I can write it as 5x can be written as 3x and 2x. I can write it as 3x and 2x. Since there is minus 5x, I'll have to write it like this, right? I can write this as minus 3x and minus 2x. So when I add these two, it's going to be minus 5x, right? This is another way. Now here I'll take common factor. Here between these two, I can take x as common. So I'll get x minus 3. And between these two, I can take 2 as common. I'll take minus 2 as common. So I'll get x. Since minus has been taken out, this will become minus. Plus will become minus. And 2 3s are. So I'll get this. Now if you notice, again here x minus 3 is common. So I'll get x minus 2. So the factors are x minus 3 and x minus 2. So there are multiple methods. 3 methods I have already mentioned. So you may need to practice all of these methods to arrive at the factors. And this is very important for resolving partial fractions related problems. So from all 3 methods, we know that the factor is x minus 3 and x minus 2. So now we'll write this as x square minus 10x plus 13 by x plus 1. We can write this as x minus 3 and x minus 2. This is equal to, we'll write a by, we'll take this one, x plus 1 plus b by this one, x minus 3 plus c by x minus 2. This one. So we've splitted these three denominator terms to three separate terms. We can take LCM, or you can multiply on both the sides by the denominator, right? Again, there are two methods. You can either use LCM or multiply on both the sides by denominator. If I multiply both the sides by the denominator, that is like this, x square minus 10x plus 30 into x plus 1, x minus 3, x minus 2. So I'll multiply both the sides with the denominator terms. So I'll get this, then divided by x plus 1, then plus b by x minus 3 into all the denominator terms, plus c into all denominator terms by x minus 2. Now, if you notice, you can cancel x plus 1, x plus 1, x minus 3, x minus 3, x minus 2, x minus 2. And here we have this denominator already on the left hand side. So here all these terms will get cancelled. So we'll be left with x square minus 10x plus 13 is equal to a into x minus 3 into x minus 2 plus b into x plus 1 into x minus 2 plus c into x plus 1 into x minus 3. So basically, other than this term, these two terms will get associated with a. For b, other than this term, these two terms will get associated with b, right? Now in this equation, we'll take values of x. We'll take x is equal to 3. We have x minus 3, so we'll take the opposite sign, x is equal to 3. Here we have x minus 2, so we'll take x is equal to 2. Here we have plus 1, so x is equal to minus 1. Now using these three values of x, we'll substitute all these values of x in this equation and get values of a, b and c, right? Now let's substitute first one with x is equal to 3. You will get 3 square minus 10 into 3 plus 13 is equal to a into 0, because 3 minus 3 is 0, and 3 minus 2, plus b into 3 plus 1, 3 minus 2, plus c into 3 plus 1, 3 minus 3, right? Now there is, since 0 here, this will become 0, plus b, 4b and 1, you get 4b plus 4, this is 0, this will become 0, right? And here we are going to get 9 minus 30 plus 13, you will get minus 8 is equal to 4b, which means b is equal to minus 8 by 4. So we get b is equal to minus 2. Now we'll find the second one. Now we'll take the second term, which is x minus 2. We'll assume x is equal to 2. So let x is equal to 2. Now take 2 and substitute in this entire equation, 1. So we'll get 2 square minus 10 into 2 plus 13 is equal to a into 2 minus 3, 2 minus 2, which is 0, plus b into 2 plus 1 into 2 minus 2 plus c into 2 plus 1 into 2 minus 3. So on solving this, we'll get 4 minus 20 plus 13, we'll get 0. This will be 3, this will be 0, minus 3c. This will be 3 and this will be minus 1. So minus 3c. And this is minus 3. Minus 3 is minus 3c. This is nothing but c is equal to minus 3 by minus 3. C is equal to 1. So now we've got the values of b and c. Now we'll have to find the value of a, right? We have taken x is equal to, we have finished x is equal to 3 and x is equal to 2. Now we'll have to take x is equal to minus 1, right? So let's take x is equal to minus 1 and substitute in this equation. So on substituting x is equal to minus 1, we'll get this particular expression. So on simplification, we'll get 12a is equal to 24. Thereby, we'll get a is equal to 2. Now that we have got all the values of a, b and c, we'll take the original expression where we had split it in terms of a, b and c and substitute the values of a, b and c. So on substituting, we'll get a is equal to 2, 2 by x plus 1, b is equal to minus 2 by x minus 3, c is equal to 1 plus 1 by x minus 2. So here we have got the partial fraction. Now let's take another example. we'll have to first check if this is a proper fraction or improper fraction. Now, look at the degree of the numerator. Degree of numerator is 1, right? There's nothing for x, no power, which means it's 1, right? So this is the degree, 1. What is the degree of denominator? You have x square. When you multiply x square with x, right? When you actually multiply, you'll get x cube. So what is the degree? It's 3. So degree of numerator is less than degree of denominator. Therefore, this is proper fraction because degree of numerator is less than degree of denominator. Here, what we'll have to do is, we'll have to first, see, basically we'll have to remove all these squares. Squares, cubes cannot be there. We'll have to get the x value to a single degree, right? We cannot have 2 as the power or 3 as the power or anything. The power should be only 1. So we have to simplify this denominator to have x values with power as 1 only. We can write this as x plus 3 by x minus 1, x square minus 4. You can write x square minus 4 as x square minus 2 square, right? And you can write this further as x plus 2 into x minus 2. You should always remember this formula. A square minus b square is a plus b into a minus b, always. So here if you have x square minus 2 square, you have to write this as x plus 2 into x minus 2. This is a very important formula used in entire mathematics. So we can split this as x plus 2 into x minus 2, right? So now we'll write this as a by x minus 1 plus b by x plus 2 plus c by x minus 2, right? And we'll copy the left hand side as is. Now, when you multiply both the sides, you can either use LCM or multiply on both the sides. I'll use the LCM method here. I find LCM method more simpler because it's going to avoid multiple steps. LCM for this will be this one. This is the LCM. Now, there is already x minus 1 here. So, you'll have to cross multiply with this. That is, we'll have to cross multiply with x plus 2 and x minus 2. So, we'll get a into x plus 2 into ax minus 2. Here again, x plus 2 is already here. So, I have to take the other two terms and multiply. B into x minus 1 into x minus 2. Now, plus c into x minus 2 is already there. So, I'll have to multiply with the other two terms. That is x minus 1 and x plus 2. Now, I'll copy the left hand side. Now, if you notice, the denominators are actually same, right? So, I can cancel. This. Now, I have this simplified expression. You'll have to take x is equal to all of these values, right? We'll have to take x is equal to plus 2 means minus 2. Minus 2 means plus 2. Then minus 1 means plus 1, right? Just reverse the signs and take those values as x. So, we'll take x is equal to minus 2 first time, right? For the first case. So, let me substitute x as minus 2 in this entire expression. So, I'll get minus 2 plus 3 is equal to a into minus 2 plus 2 is going to become 0 plus b into minus 2 minus 1 minus 2 minus 2 plus c, this is going to become 0 because minus 2 plus 2 is going to become 0, right? So, I'll get 0 plus minus 3 minus 4, that is plus 12. So, I'll get 12b plus 0 and this is 1. 12b is 1. So, we get b is equal to 1 by 12. So, we assumed x is equal to minus 2. Now, we'll take x is equal to 2. Let x is equal to 2. So, when you substitute x as 2, you will get this particular expression. 5 is equal to, this will become 0. This will become 0. So, 0 plus 0 plus 2 minus 1, 1, 1, 4. 1 into 4, 4c. So, c is equal to 5 by 4. Now, we'll assume let x is equal to 1, that is this one. Here, x minus 1. So, we'll take x is equal to 1. When x is equal to 1, so we'll get this particular expression when we substitute x is equal to 1. So, we'll get 3 minus 1. So, we'll get minus 3 plus 0 is equal to 4. So, a is equal to minus 4 by 3. Now, we'll substitute the values of a, b and c in this particular expression where we are splitted into a, b and c. So, now in this expression, we'll substitute all the values. So, we got a as minus 4 by 3, b as 1 by 12 and c as 5 by 4. So, this is the partial fractions. So, let's solve another problem which is related to repeated factors. So, when you have something like this, x plus 3 the whole square, this is nothing but a repeated factor because x plus 3 the whole square is nothing but x plus 3 into x plus 3. So, this is repeated. Since this is repeated, we call this problem as having repeated factors. So, here how we should split is, we will first take a, take x minus 2 Then we'll take B, we'll take x plus 3, and then we'll take C, same thing, x plus 3 the whole square. So once with x plus 3 and second time with x plus 3 the whole square. So this is how we'll have to split. So B with x plus 3 and C with x plus 3 the whole square. You can interchange this, right? You can have C here and you can have B here. That doesn't matter. Denominator what matters? One denominator should be x plus 3. The other denominator should be x plus 3 the whole square. So now I'll take the LCM, right? LCM for this would be x minus 2 into x plus 3 the whole square. If you're not comfortable with LCM method, then you can multiply on both the sides with all these factors, right? On both the sides you can multiply. You can multiply with x minus 2 and x plus 3 the whole square. You can multiply on both the sides. So I find this easier because it reduces one step for me. So now when I use LCM, I'll get x minus 2 and x plus 3 the whole square. So now I'll have to multiply. X minus 2 is already here. So I'll have to take this one. A into x plus 3 the whole square plus B into x plus 3 is here. One x plus 3 is here. So another x plus 3 we need to put here. And x minus 2 plus C into x plus 3 the whole square is here. So x minus 2 has to be put. So we'll get, so now denominators will get cancelled and we are left with this particular expression. Now we'll have to take the values. We'll have to take, we can take x is equal to, here it's plus 3, so we'll take x equal to minus 3. Then x is equal to plus 2. Because it's minus 2, we'll take it plus 2. Here it's the same thing, so let's leave it. So let's take x is equal to minus 3 and substitute. So on substituting x is equal to minus 3 here, we get this becomes 0. This also becomes 0. And this will become minus 5c. So we get minus 7 here. On simplification, we get c is equal to 7 by 5. Now let's put x is equal to 2, this one, right? When we put x is equal to 2, we'll get 3 into 2 plus 2 is equal to a into 2 plus 3 the whole square plus b into, so we'll get 25a plus 0 plus 0 is 8, which means a is equal to 8 by 25. So now on substituting x is equal to 2, we'll get a is equal to 8 by 25. Now we got the value of c and we got the value of a. Now we need to find the value of b, right? Now how do we find the value of b? We have already utilized this value, x is equal to minus 3 and x is equal to 2. Now to find the value of b, there are two methods. Either we have to use coefficient method or constant method. Simple. What we have to do is take the coefficients of x square from this expression. This expression, right? Here. From this expression, we take the coefficients of x square, and here also we take the coefficients of x square. And from the equation, we find out the value of b. We can also use another method called as constant method, right? First, let's figure out coefficient method. Let me copy this expression there. So we'll take the coefficient of x square here. So when you multiply x plus 3, this is nothing but x plus 3 into x plus 3, correct? This expression is nothing but x plus 3 into x plus 3. When you multiply x into x, you're going to get x square. What is the coefficient of x square? That is the number next to x. There's no number, means there is 1, right? So coefficient of x square is 1 here. So we'll put 1a. Then here, what is the coefficient? Again, it's x square. There is no number. So we assume it's 1, 1b. And here, there's no x square itself. If there is no x square, then it is 0. So it is 0c, right? Now, here also there is no coefficient of x square. There is no x square here. Since there is no x square here, we don't have the coefficient. So we'll assume it is 0, right? We are just taking coefficients from this equation. Now, we know the value of a, which is 8 by 25. B, we'll have to find out. And this is equal to 0. Now, this means b is equal to minus 8 by 25. So, here we have obtained the value of b. Now, there is another method, constant method. In this method, we take the same equation and take the constants. Constants are nothing but only the numbers. So let's take this equation. So in this equation, we'll take the constants. Constants is we have to take the numbers, only numbers without any x in it. So now, when you multiply 3 and 3, you're going to get 9, right? So now what we will do, we will take this expression. It will be 9a. Now again here, when you multiply, just numbers you have to multiply. 3 into 2 is 6 and there is minus here. So minus 6b. And here constant. Constant is minus 2, only minus 2. So minus 2c. Minus 2c. And what is the constant here? Constant is plus 2. Only number. So 2. we'll substitute the value of A. A is 8 by 25 minus 6B. B we have to figure out. Minus 2 into C. C is 7 by 5. So now we'll calculate. Now on simplifying all of this, there are multiple calculations. Basically, you'll have to take the LCM, subtract, multiply and all of that. And finally, we get the value of B, which is minus 8 by 25. Now, we got the same value for B, right? Whether we use the coefficient method or we use the constant method, we got the same value. Only reason I prefer coefficient method is here the calculations are simpler, right? But in this case, the calculations are slightly lengthy. Now, finally, you take the original expression with A, B and C, substitute the values of A, B and C, and then you get this particular partial fraction. Now, let's take another example, which is related to improper fractions. Here, if the degree of numerator is greater than or equal to degree of denominator. What is a degree? Degree is nothing but highest degree of the polynomial function. Now, this is a function. What is the highest degree of x? Degree is the power, right? What is the highest degree? It is 2. This degree of this x is 1. Degree of x square is 2. But highest degree for this entire function is 2. For numerator, it is 2. And for denominator also, it is 2. So, here degrees are equal. If the degrees are equal, then it's an improper fraction. Assume if the degree was 3, if it was x cube here instead of x square, then the degree would have been 3. Even in that case, degree of numerator would be greater than degree of denominator. So, either ways, if the degree of numerator is greater than or equal to, then we call it as an improper fraction. Every time a partial fraction problem is given, first check is to see the degree of numerator and denominator. Check if it is proper fraction or improper fraction. If it is an improper fraction, then we'll have to do an extra step of division. We'll have to divide. So we'll take this denominator here, take the numerator here, and then divide. So how do we divide? Now, here you have 2x square minus 7x plus 1. So and here we have x square. So we'll have to multiply some number with x square, some number with x square, so that we get 2x square, this first one. So we have to multiply 2. So x square into 2 becomes 2x square. Why should we do that? Because so that we can cancel the terms. So now 2x square and 2x square will get cancelled, and then we'll have to multiply these remaining terms with 2. So 2 into minus 3x is minus 6, 2 into 4 is minus 8, and then we subtract the entire thing and we get minus x plus 9. Now there are no other terms here, right? Assume that there was something else here, say 8x cube, for example. Then we'll have to bring this down, and then continue the same process, right? Now this is not there, right? So we end it up here. So this is the remainder, this is the quotient, and this is the divisor or the denominator. Now, so we will be writing this entire improper fraction like this. We'll write the quotient here, quotient plus this one, remainder, by denominator or divisor. So this one, remember this quotient always, right? In the final step, when we have splitted the partial fractions, we have to remember to add this quotient. Now we'll take this particular fraction and resolve into partial fractions. Now we get this particular proper fraction, right? Now we'll use the same method, split it up into a by x minus 4 and b by x plus 1. Now here denominator we'll have to factorize, right? We'll have to factorize this. So like I said, there are 3 methods: direct method or method of splitting, sum product method, and formula method. So whichever method is comfortable, right? So I've used all the methods here, right? If you use sum product method, sum should be minus 3, this one, product should be minus 4. And you should choose 2 numbers whose sum, that is when you add these 2 numbers, you get minus 3, and when you multiply 2 numbers, you get minus 4. So now you'll have to guess. You'll have to guess what those numbers are. So immediate guess is minus 4 and 1, because minus 4 into 1 is minus 4. Minus 4 plus 1 is minus 3. So you'll get minus 4 and 1 as the numbers. So we'll have to write it as x minus 4, and this plus 1. So x plus 1. So these are the factors. So now you'll have to write these factors here. Okay. Then the normal process, you split it up into a and b, and then you take the x values. Here x will be minus 1 and here x will be plus 4. Now substitute x is equal to minus 1 and you'll get the value of b. Then you substitute x is equal to 4 and then you'll get the value of a. Now you substitute a and b values and you get the final answer. But remember to put the quotient, right? Most of the times we forget to put the quotient. Since this was an improper fraction, we'll have to put the quotient here. Quotient we had got was 2. This was the quotient we had got. So finally we have to add 2 to this entire partial fraction. Now let's take another example. Here there is x cube and denominator has x square. Highest degree. What is highest degree here? 3. Highest degree for numerator is 3 and highest degree for denominator is 2. So numerator degree is greater than denominator degree. Therefore, this is an improper fraction, right? Now, since it's an improper fraction, we will divide. So we'll take this denominator here, put the numerator here, and now let's solve this step by step so that it becomes clear. So now what I will do, I'll take this x square first, right? And here the first term is x cube. Now I have to multiply this x square with something so that I get x cube. Now if I multiply x square with x, I'll get x cube, correct? So I'll have to put x here and then multiply. X square into x is x cube. Now I'll take this remaining terms and multiply with this. So 5x into x is 5x square. 6 into x is 6x, right? Let me subtract everything. So when I subtract, x cube and x cube will get cancelled. So when I subtract this, I'll get 2x square plus 11x, and then I'll carry forward this one. I'll carry forward this one plus 11. Now I'll have to continue this one more time because I carry forwarded this number. I have to do this entire cycle once again. Now I'll have to do the first term, which is 2x square. What should I multiply with x square so that I get 2x square? It should be 2. So let me first put plus. I should multiply with 2 plus 2. X square into plus 2 is 2x square. Now let me multiply this entire thing with 2. So I'll get 2x square. 5x into 2 is 10x. 6 into 2 is 12. Now let's subtract. This will get cancelled. And I'll get 11x minus 10x is x. 11 minus 12 is minus 1. Now there is nothing to carry forward. Thereby I end it here. So this is the remainder, right? This is the remainder. This is the quotient. And this is the denominator or divisor. Remember this quotient because we are going to add this finally to the partial fraction. This is how the polynomial function will be, right? X plus 2 plus this expression. We'll have to put the quotient here plus the remainder and then the divisor. So this is the final polynomial function. Now we'll take this proper fraction and we'll use the normal process of finding values of a and b. We'll split this, find the value of a and b, right? And then we get the value of b, we get the value of a. We substitute in this equation, right? And then finally put the quotient. Right? Let's not forget this. So with this, we have come to the end of this particular topic. Thanks for watching. Hope this video was useful.